Hi everyone, we are going to see the problem which we have discussed in the last video. So basically rotating an array by k steps. We had performed it using reversal of array and it required 3 steps there, and each element was we had to visit each element twice. So this is one more optimal way which you can try, and it is based on cycle replacement algorithm. So we are just going to see how it works basically via the code part, and then I will walk you through the example. So given the array, we are going to maintain two counters here, start and count, and so we are going to have two loops here. One is to check whether the counter is less than array, less than the number of elements, and we are going to maintain one current index and one previous value. You will see it why it is happening. So current index will have the initial value as start, and previous value is going to have the element which is present at the start, and then we are going to iterate it. So basically a concept of more than one cycle can also come. You will see in the example how it comes. So while true, we are going to compute the next index via this GCD formula. So basically it is modulo, and what we basically do is whatever element is present at this position, we are going to assign the previous value to it, and the previous value is going to contain this particular value which is at present. This is the basic idea, and then we increment the counter, and current index is also increments to the next index, and we break if again we are going to reach if one cycle is complete. So basically if start is equal to current index means your cycle is complete, so you break it and you increment the position of the start. So next time it is going to start from 1 and not from 0. It will be more clear when we go through via example. So you are given an array 1 2 3 4 5 6. So initially you will have start as 0, and this value is equal to 1. So position 0 you have value 1. So this is we are putting in a temporary variable. In the target we are going to calculate via this modulo. So at position 2, so 0 1 2 you have value 3. So we are going to swap it. So now your temporary variable will have the value 3, and your array looks like this. So 0th position your value having is 1. At the second position you are having value 1 which is getting assigned. Now the iteration continues. So fourth position the value which is present is 5, and so temporary will become 5, and your array after this swap looks like 1 2 1 4 3. You remember last time we were having the value 3, so this 3 is getting assigned here. And the next iteration, see this is what I am telling, this is the cycle. So 4 plus 2 is equal to 6, mod 6 is equal to 0. So you complete one cycle is complete now. So your start counter will increment by 1. Now what we are going to see, at 0th position you have the value 1, and temporary variable is having the value what, 5. So we are going to assign this 5 to this position, and array looks like this 5 2 1 4 3 6. Now still our counter is not complete, we have not iterated all the elements. So we are going to see the next cycle. So it starts from so now the index starts from 1. So initially your temporary will have this value because index is 1, so 2 is here. Now next index gets computed, which is 3. So here the value is 4, and this particular 2 is going to get assigned at this position. So your array will be 5 2 1 2 3 6. Now next time your index becomes this 5. So fifth, the value at fifth is going to get assigned to temporary, and the element at fifth is going to have the value which was present there previously. What was the previous value? This was 4. So 4 is going to come at the fifth position. And now after this you are having index is equal to, see, mod 6 you are having index is equal to 1. Now value at 1, what is the value at 1? This is 2, and your temporary variable was having 6. So at second position you are going to insert 2, and you remember this was the count, this was our counter. So we have one more condition here, start is equal to this is, so this is not true, we are not going to break because of this. But your counter, you remember this counter, now counter we have iterated all the elements, so we are going to break. So this one is little better compared to the reversing the array, because each element is traversed only once. So computation time is less, but yeah, time complexity remains the same, and space complexity also remains the same. So this is one more way. It is always good to learn more ways to approach the problem, so that we can see the patterns sometimes when other problems comes. So okay, I will share the code for this. This is the Python implementation. I will share the notebook for it. Okay, thanks and happy learning.